All right, in this section, we're going to talk about probabilities. Probabilities are between 0 and 1. That's what the numbers can be between 0 and 1. If you're talking percents, it's 0 to 100. The closer the probability is to 1, okay, the more likely it is to occur. If the probability is closer to 0, the less likely it is to occur. An experiment is what we're going to be talking about. So you'll see the E used for event or your experiment. Sample space is all possible outcomes, okay? And we denote this as S when we use the notation. The sum of all possible outcomes is 1. In other words, if you add up the probability of everything that can happen, it will equal 1. So in this formula, the probability of an event, okay, or an event is what we call them. It's the number of outcomes of the event over the total number of possible outcomes. Now we're talking about theoretical probability when we talk about this event. So let's explain what theoretical probability is. That's when we use probability for things that we assume are going to happen or we know are going to happen. Like we use dice. We know the number of dots on dice. We use cards. So we didn't actually do an experiment. That will come next. This is theoretical probability, and we use what we already know. It says, what's the probability that a die is rolled once, and you're going to get a 3 for part A, and in part B, an even number. So let's talk about the sample space for a dice. There's 1, 2, 3, 4, 5, and 6. That's your possibilities on a dice. One side has 1 dot, one side has 2 dots, and so on. Okay. Now, the probability we get a 3. Well, 3 happens one time out of the 6. So the probability would be 1/6. Rolling an even number, okay? Well, let's look and see what's even. 2's even, 4's even, and 6 is even. Out of this sample space, those are even. So that would be 3 out of a grand total of 6. There are a total of 6 in the sample space. 3 out of 6 reduces to 1/2. You do need to reduce your fractions. You can write probabilities as decimals and as percents. If you write it as a percent, make sure that you include the percent symbol. On the next one, a die is rolled once. Find the probability of rolling a number less than 5 in part C and a number less than 10 in part D. Okay, so here's my sample space. It hasn't changed. How many numbers on there are less than 5? Okay, 1, 2, 3, 4. So there are 4 numbers less than 5. Okay, so that would be the number of events. Over the total number in the sample space is 6. 4 out of 6 are less than 5, and that reduces to 2/3. For D, rolling a number less than 10 is our event. Well, they're all less than 10. That's 6 out of 6, and the probability is 1. So when something is definitely going to happen, the probability is 1. Now on the next example, rolling a number greater than 6. Well, our sample space is 1, 2, 3, 4, 5, and 6. There are no numbers greater than 6. It's not possible. So it would be 0 out of 6, and the answer would be 0. So anytime something cannot occur, the probability is 0. Now let's look at one with cards. So you're dealt one card from a standard deck. Find the probability of being dealt. Okay, now if you don't know about cards, you do need to look that up. You can find a picture and print it off online. There are 52 cards in the deck, but you will need to look that up. There are 4 sets. You have hearts and diamonds that are red, and you have spades and clubs that are black. There's 13 in each set. And it goes from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. The jack, queen, and king are the only face cards, and there's 1 of each set. So for a king, there are 4 kings out of 52 in a standard deck. That reduces to 1/13. Probability of a heart, there are 13 hearts out of 52 in that deck. That reduces to 1/4. Probability of the king of hearts. Well, there's only 1 king of hearts. So that would be 1 out of 52.